Welcome to this video which is about pipe and cistern. That is, how can we solve the pipe and cistern related problem. In this video, I will discuss many types of pipe and cistern related problem with the help of just one formula. After finding type-wise formula, then I will try to use that formula as shortcut to solve any problem within few seconds. For every pipe and cistern problem, there will be some pipe for flow in and some pipe for flow out, and there will be a cistern, or you can say a tank. Every pipe must have a rate of flow. The pipe which fill the cistern or tank, that pipe have rate of flow in, and the pipe which makes cistern empty, that pipe have rate of flow out. So what is rate of flow in or out? The amount of fluid flow in or flow out by the pipe in a unit time is called rate of flow in or rate of flow out. So what will be the equation for rate of flow in or out? That is Q in or out. In case of Q in, that is called rate of flow in, and for Q out, which is called rate of flow out. So Q in or Q out is equal to Vt divided by T. Here, this Vt is the amount of fluid in time t. With this rate of flow in or out, we form a final equation which is T into Q in minus Q out equal to V. Here, this Q in minus Q out is the amount of fluid in unit time. This T is the total required time to fill the cistern when all the pipes are open, and this V is the volume of the cistern. So Q in or Q out equal to plus minus Vt divided by T. Here, this Q in or out is the rate of flow, this T is the time, and this Vt amount of water after time T within the tank, and this plus minus is sign for the flow in or flow out. In case of flow in, the sign is positive, and in case of flow out, the sign is negative. And for the final equation, T into Q in minus Q out equal to V. Here, this Q in is the rate of flow in, Q out is the rate of flow out. So this Q in minus Q out represent amount after unit time. This T represent the total required time when all the pipes are open, and this V is the volume of the cistern. So this is our equation. With this equation, we can easily solve all the types of pipe and cistern related problems. Let's see how much time we need to solve any problem using shortcut rules. Here, one problem. Two pipes can fill a cistern in 10 and 15 hours while working alone. If both the pipes are open together, then find the time taken to fill or empty the cistern or tank. For this type of problem, the shortcut is the multiplication of these two numbers, that is the required time for first pipe and the required time for the second pipe. 15 into 10 divided by 15 plus 10. So the result is 150 divided by 25, which is equal to 6. So if we know the shortcut rules, we can easily solve this type of problem within few seconds. Let's see another type of problem. A pipe can fill a cistern in 10 hours. Because of a leak in the bottom, it is filled in 15 hours. If it is full, find the time taken the leak to empty the cistern. For this type of problem, our shortcut is the multiply these two numbers divided by the subtraction of this number. From large number, the subtraction of the smaller number. That is 15 into 10 divided by 15 minus 10. So the result is 150 divided by 5, which is 30. That is, the second pipe needs 30 hours to empty the cistern. So if we know the shortcut, we can easily solve this type of pipe and cistern related problem within few seconds. Before that, we have to solve it in details. For this, now the problem solving steps. That is, how can we solve this type of problem? Number one, find Q in or out, which is equal to plus minus Vt divided by T. Number 2, find the amount after unit time, that is Q in minus Q out. In this case, if more than one flow, then add here, that is Q in. We just add all the Q in, and in case of flow out, more than one flow out, that case we just subtract the flow out here. So we can say add all flow in and subtract all the flow out. That case we will get the amount after unit time. Number 3, simplify the final equation to get the result. Our final equation is T into Q in minus Q out equal to V, and this T, we all know this one is the required time when all the pipes are open, and this V is the volume of the cistern. Let's see the type 1. Two pipes can fill a cistern in X and Y hours while working alone. If both the pipes are open together, then find the time taken to fill or empty the cistern or tank. Here, both the pipe is for filling the cistern. So let's solve this problem according to the steps. Let the volume of this tank is V and the total required time which we want to find, that is T. So step 1, find Q in. So both the pipe are for flow in. The first pipe need X hour to fill the whole tank. So the rate of flow in is the volume of the whole tank divided by the required time. That is Q in for the first pipe is V by X. And for the second pipe needs Y hour to fill the full tank. So the Q in for second pipe is V by Y. Now step number 2, find the amount after unit time. Here both the pipe are for filling the cistern or tank. So both the rate of flow will be added to find the amount after unit time. That is Q in for first pipe plus Q in for the second pipe. And simplify the final equation. That is T into Q in plus Q in, which is equal to V. So just substitute the value of Q in, which is V by X, and this Q in, the value is V by Y. So T into V by X plus V by Y, which is equal to V. Now if we take the V common here, then TV equal to 1 by X plus 1 by Y, which is equal to V. Then cancel the V from both sides. Then T into just taking LCM of X and Y, that is XY, then X plus Y, which is equal to 1. Then T equal to 1 divided by X plus Y divided by XY, and which is equal to XY divided by X plus Y. So this is our required result, that is XY divided by X plus Y. Let's see one example of this type, that is two pipe can fill a cistern in 10 hours and 15 hours while working alone. If both the pipe are open together, then find the time taken to fill or empty the cistern of tank. So in this case, let the volume is V and total time which we want to find, that is T. Then the Q in for the first pipe, that is V by 10, since first pipe need 10 hours to fill that full tank. And Q in for the second pipe, that is V by 15, since the second pipe need 15 hours to fill the tank. So find the amount after unit time, that is Q in plus Q in, because here both the pipe fill the tank. That's why the amount after unit time, that is Q in plus Q in. And the final equation is T into Q in plus Q in is equal to V. Here T is the total time and V is the volume. This one is the amount after unit time. So just substitute the value of Q in here, that is V by 10 and V by 15 here, which is equal to V. And taking V common, that is TV equal to 1 by 10 plus 1 by 15, which is equal to V. And cancel this V from both sides, that is T into just LCM of 10 and 15, that is 30, that is T plus 2. which is equal to 1. So after simplify, we get the result t equal to 6. If both the pipes are open, then the total required time to fill the tank is 6. Let's solve this problem using the shortcut formula. That is xy divided by x plus y. The value of x is 10, the value of y is 15. So if we substitute the value here, that is 15 into 10 divided by 15 plus 10, then we get the required result 6. Now, the type 2. One pipe can fill a cistern in X hour while working alone. Another pipe can empty the full cistern in Y hours. If both the pipes are open together, then find the time taken to fill the cistern or tank. So first, let the volume of the tank is V and total required time is T. So first step, that is find Q in. Here, the first pipe is for flow in and the second pipe for the flow out. So Q in equal to V divided by X, since the first pipe need X hour to fill the full tank. So the volume of full tank is V and required time is X. So Q in equal V by X, and the Q out, which is equal to V divided by Y, because the second pipe need Y hour to empty the full tank. So the volume of the tank is V and the required time is Y. So Q out equal to V by Y. Now step number 2, find the amount after unit time. So first pipe is for flow in, second pipe is for flow out. So the amount after unit time will be Q in minus Q out, and the final equation, that is T into Q in minus Q out, which is equal to V. Here the T is the total time and V is the volume of the tank. Just substitute the value of Q in here, that is V by X, and the Q out here, that is V by Y. So T into V by X minus V by Y equal to V. Taking V common, that is TV into 1 by X minus 1 by Y equal to V. Then after simplification, we get the result, that is T equal to xy divided by y minus x. Let's see one example of this type. One pipe can fill a cistern in 10 hours while working alone. Another pipe can empty the full cistern in 15 hours. If both the pipes are open together, then find the time taken to fill the cistern or tank. So, at first, let the volume of the tank is V and total required time, which we want to find, is T. Step number 1, flow in, that is Q in. For the first pipe, the first pipe need 10 hours to fill the full tank. So Q in equal to V divided by 10, and the second pipe can empty the full tank in 15 hours. So Q out is equal to V divided by 15. According to the rules, amount after unit time is Q in minus Q out. The final equation, that is T into Q in minus Q out equal to V. Just substitute the value of Q in, that is V by 10, and Q out V by 15. We just simplify, that is TV equal to 1 by 10 minus 1 by 15 equal to V. After simplification, we get the required result, which is 30. So if we want to solve this problem using the shortcut rules, then the shortcut is xy divided by y minus x. Here, the value of x is 10 and the value of y is 15. So substitute the value of x and y, we get the result 30. So if both the pipes are open together, then the required time to fill the tank or cistern is 30 hours. Let's see type 3. A pipe can fill a cistern in X hours. Because of leak in the bottom, it filled in Y hours. If it is full, find the time taken by the leak to empty the cistern. Here, this leak, we can consider this one as a pipe for flow out. Let's solve it. Let the volume of the tank is V and the required time for the leak to empty the tank is T. The first step, the Q in, that is V by X. That is, a pipe can fill the cistern in X hours. So the volume of cistern is V and it required X hour to fill the cistern. So V by X gives the flow in, the rate of flow in. And we let here the time taken by the leak to empty the cistern is T. So the Q out is V by T. That is, the leak need T time to empty the full tank, that is full volume of the tank. That's why Q out equal to V divided by T. We are going to find the value of T. Now find the amount after unit time, that is Q in minus Q out. One pipe is for flow in and one leak for flow out. Now simplify the final equation, that is Y into Q in minus Q out is equal to V. Here the required time, that is total time, is Y hours, because when the leak and the pipe both are open, it requires Y hours to fill the full tank. That's why total required time is here Y. That is Y into the amount after unit time, that is Q in minus Q out, which is equal to V. So substitute the value of Q in V by X and the Q out V by T, which is equal to V. Then we can write V by X minus V by T is equal to V by Y. And we can write V by X minus V by Y, which is equal to V by T. And cancel the V from the both sides. Then 1 by X minus 1 by Y equal to 1 by T. After simplification, we get the result T equal to XY divided by Y minus X. So the leak need XY divided by Y minus X time to make the full cistern empty. Let's solve one problem related to this type. A pipe can fill a cistern in 10 hours. Because of a leak in the bottom, it filled in 15 hours. If it is full, find the time taken by the leak to empty the cistern. So let volume is here V. The required time for the leak to empty the cistern is T. Step number 1. Find Q in, which is V divided by 10, since the pipe can fill the whole cistern in 10 hours. That is Q in equal to V by 10. Here we let the time taken by the leak to empty the full cistern is T. That's why the Q out is V by T. Find the amount after unit time, that is Q in minus Q out. And the final equation, that is total required time 15 into Q in minus Q out, which is equal to the volume of the tank. Substitute the value of Q in here, V by 10, and the Q out, that is V by T. Here, V by T, which is equal to V. After simplify, we can get the result T is equal to 30. So the shortcut for this type of problem is xy divided by y minus x. Here the value of x is equal to 10. So the value of y is equal to 15. So xy divided by y minus x. That is 15 into 10 divided by 15 minus 10, which gives the value 30 hours. Now, type 4. A cistern has a leak which can empty it in X hour. A pipe which fills Y liter of water per hour into the cistern is turned on, and now the cistern is empty in Z hour. Find the capacity of the cistern. So in this type of problem, we are going to find the volume of the cistern. Let the volume of the cistern is V. Step number 1. Find Q in and Q out. Here, a pipe which fills Y liter of water per hour, that is Y liter in 1 hour. So Q in is Y divided by 1. And the Q out, that is rate of flow out, that is a leak can empty it in X hour. So the volume of the cistern, that is V divided by X, is the Q out for this leak. Number 2, find the amount after unit time, that is Q in minus Q out. Here, the final equation is V plus Z into Q in minus Q out, which is equal to 0. Here, Q in minus Q out is amount after unit time. Here must be this Q out is larger than Q in. That's why finally the cistern is empty. So V plus Z into this Q in minus Q out. Finally the cistern is empty. That's why the final result is 0. So V plus Z into Q in minus Q out, which gives the result that is 0. Finally the cistern is empty. Just substitute the value of Q in, that is Y, and Q out, V by X, which is equal to 0. After simplification, to get the required result, that is V equal to X, Y, Z divided by Z minus X. So this is our final result. The volume of the tank is XYZ divided by Z minus X. Let's see one example of this type. A cistern has a leak which can empty it in 10 hours. A pipe which fills 2 liters of water per hour into the cistern is turned on, and now the cistern is emptied in 15 hours. Find the capacity of the cistern. So let's the volume is V and the Q in is 2 liters per hour, so 2 by 1, and Q out, the leak can empty it in 10 hours, that is empty the full volume of the cistern in 10 hours. That's why Q out equal to V by 10. So amount after unit time, that is Q in minus Q out, and the final equation as previous, that is V plus 15 into Q in minus Q out, which is equal to 0. When the pipe which are for flow in and the leak for the flow out both are open, then it required 15 hours to empty the tank. So 15 into Q in minus Q out, if we add this with the full volume of the tank, which gives the final value, that is finally the tank is empty. So V plus 15 into Q in minus Q out is equal to 0. So substitute the value of Q in here and the Q out here, we get V plus 15 into 2 minus V by 10, which is equal to 0. And after simplification, we have the result V equal to 60. So our required result is V equal to 60 units. So if we want to solve this type of problem using the shortcut, that is in this case the shortcut is X, Y, Z divided by Z minus X. Here this X is required time for a leak to empty the tank. This Y is for the pipe which fill some amount of water per hour, and this Z is the total time when both the leak and the pipe are open. So here the value of X is 10, the value of Y is 2, and value of Z is 15. So X, Y, Z divided by Z minus X, which gives 10 into 15 into 2 divided by 15 minus 10. 300 divided 5, which is equal to 60. So our required result is 60.